Okay. Good afternoon. My name is Alan White. This is Eddie Jasinski, Wes Rumble, and Shannon Ramey. We are Group 7, and our project is the subterranean radio. We will present our presentation and then open up the floor for questions if you have any.
All right, first we're going to go into a little bit of the background of software radio and subterranean communications and the history of it. And also we're going to go into how it's implemented and our goals, which are, and our challenges we're going to face during our next couple months. And also our conclusion, also other applications of software radio, not just the
As I'm sure we all know, the mining industry is a dangerous one. The accidents we have here are examples in recent past. Most recently with Upper Big Branch just under a month ago. While that was not directly related to communications, Sago in 2006 was. And as a result, President Bush passed the Mine Act of 2006, which was the legislation that pushed through an enforcement of new communication systems. That the mines had to provide a two-way medium for communications in emergency situations, along with other provisions to do with communications not directly related to radio. However, the radio systems, the desire was a fully wireless two-way medium. And within a few months after the passing of the Miner Act, they realized that their timetable was too tight, and they've allowed for other types, which is actually on the next page. But it's, as it says, the communication between the surface and the underground is our solution, because we want to try and build something that is in compliance with the Miner Act, because as of right now, there isn't anything on a large scale that is fully two-way wireless. So our goal is to communicate directly through the earth, which at low enough frequency, signal can propagate without any wires or any other infrastructure other than the units themselves. So what we plan to do is implement a software-defined radio, which in its simplest terms is when you have a typical radio that broadcasts, the hardware within the unit is what tunes it. Like your radio in your car, the old analog radios, you turn the dial, it changes the components within to change what frequency it's tuned to. The beauty of the software-defined radio is it does away with all the hardware, and you can hard code the tuning much easier with nothing but programming on your computer. So we're looking to utilize that to cut back on hardware costs and make it more adaptable to the environment. This is just an outline of the history of what communications have been used in the mines in the past. There's a traditional coax telephone system that runs on like a twisted pair telephones from one station to another, all through the mine from the surface down. That's pretty much the oldest that's still in use. The leaky feeder, this is a diagram of how the leaky feeder works. It's coax with your TV cable, but bigger. And how it works is it sends the signal down the conductor here with the shielding that's the ground to keep the signal in the line is actually cut in different ways. It's cut, it can be milled, but basically the signal actually leaks out of the ground, right out of the shielding. So they carry handheld receivers and it receives it, but you still need infrastructure. And the other is trolley radio, which uses the rail system for the mine cars. But in any situation, the bottom line is if there's an explosion, all the infrastructure is going to be blown out, which any of these systems that kills it.
So, like Wes said, these accidents and things that happen in the mines that cause explosions and different things can cause like everything that's in there to be stripped out, and then the cables don't work, there's no power, there might not be any water, there's no infrastructure at all. So that's what brings about this need for a wireless communication system, because there's no wires, so it has to be wireless.
And to say that there isn't current systems that transmit through the earth would be false. The Hay phone and the PED are both two current systems that exist that transmit through the earth. The Hay phone requires a lot of power. It's mainly used by cavers, and it's not practical for mining applications. And then the PED is only deployed in one mine, that's in Australia. It's like two-way texting through the earth, and wouldn't, once again, meet the goals that we're trying to accomplish with our project. Both of these solutions are expensive, they don't fit the needs of the miner, and they aren't widely deployed. For a company to develop some kind of a system would require them to invest a lot of resources, and there's only so many mines in the country that they could deploy the system in. So it's not exactly economically viable yet to make a through-the-earth communication device.
Okay, so what we're hoping to do to implement this is to use Gnu Radio, which is, like Wes talked about, a software radio, which just kind of allows you to design your radio without the hardware. It's a software, completely software implemented device, and it has all the filters and everything built into it. Like Wes said again, or no, I don't know, somebody said it. We plan to use low frequencies because they're able to propagate through rock and that kind of thing without some kind of wire to carry the signal. We plan to use frequency hopping because it's such a low frequency that it would take 10 minutes to send a 3-word text message or something. So we plan to use frequency hopping with spread spectrum to try to send more than one bit of information at a time. The whole system will be off-the-shelf hardware like a netbook or just a laptop or something, and some cable to make a loop antenna and some ferrite to put inside the antenna.
But none of this is set in stone, with the exception of the off-the-shelf hardware. The antenna situation is something we're currently investigating. As of now, we're set on a loop antenna with a ferrite core, but that could change, and there's some information that they recently learned in their antennas class about a conical antenna that we might investigate. So there's possibly better solutions to the problem of the antenna.
Basically, the problem with that is the loop antenna is directional, which is what we want, because we're going to try to go from underground to the surface. However, the lower the frequency, the bigger the antenna. But at the same time, you have to power the antenna, and the power regulations from the ground are pretty strict. So we're hoping to do some research over the summer, maybe the next semester, to deal with, as Alan was saying, with a multiple element loop antenna. So you don't have to, there's a way you can design it to drive one with a low amount of power and have it induce it through the different loops. So that's what we hope to do to boost the signal, but there's still some research to be done there.
Some of the goals of our system are to provide communication system between surface and underground personnel via wireless two-way